Sound like Preta Barasi, man.
Guys, we want to do in short the installation test. Now, among the pages I've given you now, you will see there's an installation test, which is second on the third one actually. Now, in front of your papers, I have given you this. This is SANS 10142. Now, SANS 10142, you see there it starts at 253, page 253. Now, from page 253, there's 14 tests that you normally do for an installation when you do a COC, a certificate of compliance. Right? Now, remember when you do a certificate of compliance, you must be a registered installation practitioner. Right? Somebody with a wireless license, sure. Now there's 14 tests. But what we are doing just a short version of it. So this test that we are doing is not a COC. It's just an installation test report after that. Now, in this test report we are going to do, we are just going to pick out 4 or 5 of the tests in this software. Right? Now, those tests are not the first one. The first one in that piece of paper is actually one. Now, what it has to do with the pen and napkin that is bonding all the external metal parts on the insulation. In other words, if you have a metal roof, you have any metal, your geyser, anything that has metal, you have to bond it to make sure that it is safe. That is the idea. So that if your live wire will come loose and you touch the metal part, you should actually safety. Therefore, we have an conductor. If there's no conductor there, it will touch the metal part and will then make the metal part live. Because metal is a conductor. And then whoever comes and touches that metal will shock. But if there's enough conductor, making that metal safe, as soon as that live wire touches it, it will turn. Okay? That's the work of the electrical. Its job is to safeguard the installation. Now, that's the first test. Now, according to the regulation, if you look at this, you find that SANS says the measurement that you should get, your resistance that you should get, should not exceed 0.2 ohms. Okay. Now, the second test is also to do with the earth continuity conductor, but this one is the maximum resistance. Listen to what I'm saying. Maximum resistance of the earth continuity conductor. You get it? Can you repeat it? The maximum resistance of the earth continuity conductor. The maximum resistance. Now, that test is somewhat different. In other words, if your multimeter gives you a reading more than 0.2, you're not going to jump over the roof and fall off the table because something is wrong, right? Therefore, there's a table 8.1, right? So, that is on the second page, right? You have table 8. Right, now, what does table 8.1? Table 8.1 gives you the maximum resistance of your conductors according to their sizes. But remember, the conductors according to their sizes work from a breaker that has temperature. So if it's a light circuit, the light circuit is wired with 1.5 wire. If it's a socket, it's a 2.5 conductor. The increase of the conductor means the increase of the temperature on the breaker. You get it? So for a light circuit, you will find that we have a 10 amp breaker. Okay? So the 10 amp breaker then is the one on the left hand side, gives you the temperature. You get it? So on the left hand side, it will tell you if that conductor comes from a 10 amp breaker, what will the temperature, what will the resistance require, the maximum voltage. Right? So now, remember, in bonding we said it should not exceed 0.2. But now we find that there is a maximum of it. Right? So, the second test, it works from this point. Now this point is called the consumer point of control, the CPC. The consumer point of control. Now, you see your earth conductors are all accumulated. Okay. So the one coming in from the municipality comes in. And then every one of the installation is put in to make them also safe. You understand? You get it? Okay. Now, what is the role of an ESCOM? The role of an ESCOM conductor, for those of you that do is to take faulty current or overload current down to the mesh of the ESCOM. You get it? That's the role of it. Did you know that? Right now, so all the other earth conductors in the whole installation meets the one that was brought from the outside, from the municipality. Okay? To make them all safe. Okay? So all the faulty current in this installation, if there's a faulty current or there's overload current, maybe it's the lightning or whatever causing that. Take it to that point, into the one that was brought in. And we normally take one of those conductors from there and we take it into a peg, an F peg. We call it an F peg. It's a long F rod that we hit into the ground. And then we claim the F conductor from the inside onto the. Hence we are saying it goes into the mess of the okay. Now, so the second test also then comes from this point of view, as consumer, because if you have an installation, you have a house or a big building like this, you are still consuming because you consume the electricity, so you will consume. So that point is a consumer point of view. Okay. Now, from this point, all the F conductors there is loop. Hence, therefore, that second test is the continuity, the maximum resistance of the continuity of the F conductor. Okay? So whether it's the light, whether it's the stove, whether it's the socket, whether it's the keys, all there is go from here and move to here. You get it? Now, so this one, if the resistance is more than 0.2, I go to table 8.1, so that table 8.1 will tell me if that conductor that I now test, what temperature comes from, and then I put there on the table. And you will find there that most of them are more than 0.2. You get it? But as the the breaker size increase, the resistance decrease. Can you see that? Can you see as the breaker increase, you get to 63 and you find you sit there with 0.146. That is less than 0.2. And you see it has decreased while the temperature of the breaker has increased to 63. Right? Now, in this piece of paper I have given, SANS describe how the test is done. So you should be reading this because SANS says how you must do and conduct the test. Right? So you shouldn't even be having me standing in front of you telling you. If you read this, you should know how to do it. Hence, an electrician should have a SANS book because the SANS book is the Bible. The SANS book is the one that tells you how an installation must be. You heard when we were doing the motors, SANS told us how to know the difference